Baggage and cargo are usually accommodated in compartments, commonly known as holds, in the pressurized area of the aeroplane under the main cabin floor. The compartments are heated and feature fire-resistant side walls, ceiling and walkways, smoke detection and fire protection. Cargo compartments usually have a maximum floor loading limit, mass per unit area. For example, kilograms per square meter, to protect the floor against structural damage. Additionally, the compartment may have a maximum running load limit, mass per linear length, for example, kilograms per meter, also to protect the floor against possible floor structural damage. Floor protection will be fully explained later. Units other than kilograms per square meter and kilograms per meter can be used. Baggage and cargo can be loaded into standard-sized containers designed to fit and lock into the cargo compartments. The container on screen will have an individual maximum mass limit and an individual floor loading limit, mass per unit area. Baggage and cargo can be loaded onto standard-sized flat metal pallets and restrained with load-limited straps or nets. The pallet, on screen, is typically fitted in the forward cargo area and is locked to the floor. Loose baggage or cargo can also be loaded in a specially reserved area aft of the rear cargo compartment. This type of load must be restrained by a net attached to the floor, walls and ceiling. The floors of the passenger cabin and the cargo areas of the aeroplane are limited by the maximum load that they can carry. Placing excessive loads on the structure may not only cause visible panel creasing and localized indentations, but could accelerate structural fatigue. Fatigue is cumulative and can lead to major structural collapse with little or no warning. Floor loading limitation may be defined by linear loading, also known as running load, and by area loading. Linear load is restricted by mass per unit length, and area load is restricted by mass per unit area. Let us look first at linear or running loading limitations. The linear or running load limitation, pounds per linear foot or kilograms per unit inch, protects the underfloor frames from excessive loads. The limit is set as the maximum permitted load in any 1 foot, inch or meter length of the floor, irrespective of load width. We can find by simple formula 3 options available to position the load on the cargo compartment floor and whether any one of them would exceed limits. On screen, we can see that finding maximum running load is achieved by dividing the cargo mass by the shortest length. The middle running load is achieved by dividing the cargo mass by the mid-length. The minimum running load is achieved by dividing the cargo mass by the longest length. Let us put some figures to the 3 options previously discussed in an example to find running loads. An item of cargo of mass 1000 kilograms with dimensions of 0.5 meters by 1.5 meters by 2.5 meters has to be placed in the cargo hold. We are required to calculate the maximum and minimum running loads. To calculate maximum running load, divide the mass of 1000 kilograms by the shortest side, 0.5 meters, which gives a running load of 2000 kilograms per meter. To calculate middle running load, divide 1000 kilograms by the middle side, 1.5 meters, which gives a running load of 666.7 kilograms per metre. To calculate minimum running load, divide 1,000 kilograms by the longest side, 2.5 metres, which gives a running load of 400 kilograms per metre. Let us look at an example of calculating the allowable linear load distribution where a box of mass 50 kilograms is to be placed on a cargo floor whose linear loading limit is 4.5 kilograms per inch. The box must be placed in the best position in order that the floor linear limit is not exceeded. Place the 50 kilogram box, measuring 20 inches by 10 inches square, in position shown on the screen. And divide the mass 50 kilograms by the shortest length, 10 inches, which results in a linear load of 5 kilograms per inch on the floor frames. The effect of loading the box in this position is unacceptable, because the loading limit of 4.5 kilograms per inch would be exceeded. The acceptable way of placing the box is to rotate it 90 degrees from the previous position on the floor frames. Dividing the mass, 50 kilograms, by the longest length, 20 inches, will give a linear load of 2.5 kilograms per inch. The linear load is now well within the limit of 4.5 kilograms per inch. We can conclude now that it is not just a matter of placing a load in any position on the cargo hold floor without first considering the effect on the underfloor frame structure, and in this case, linear limitations. As far as running or linear loads are concerned, it is always best to place the longest length in a fore or aft direction so that the load can be supported by as many frames as possible. We can now look at the other aspect of loading limitation, known as area load or distribution load intensity. In the case of area loading, heavy loads on a small area lead to a high load intensity, affecting floor fatigue life, leading to possible floor damage. To ensure that damage does not occur when loading onto a compartment floor, the load should be spread across the greatest area to keep the load intensity low. This is achieved by placing the load's greatest area in contact with the floor. On screen, we can see that the minimum floor intensity is achieved by dividing the cargo mass by the largest area, and the middle floor intensity is achieved by dividing the cargo mass by the middle area, and the maximum floor intensity is achieved by dividing the cargo mass by the smallest area. To help our understanding of floor area or intensity loading, let us use some values and units in a practical example. Consider an item of cargo of mass 1,000 kilograms with dimensions of 0.5 meters by 1.5 meters by 2.5 meters to be loaded into a cargo compartment. We are required to calculate the maximum and minimum floor intensity. To calculate the maximum floor intensity, we must divide the mass, 1,000 kilograms, by the smallest area, 0.5 by 1.5 meters, which results in an intensity of 1,333.3 kilograms per square meter. We can now calculate the minimum floor intensity by dividing the mass 1,000 kilograms by the largest area 1.5 by 2.5 meters. which results in an intensity of 266.7 kilograms per square metre. Now that we have understood the theory of and restrictions imposed on linear or running and area or intensity loads, it is time to apply some logic to see if and how a load may be carried without exceeding limits. Let us look at an example of a box of mass 1000 kilograms with dimensions of 0.5 meters by 1.5 meters by 2.5 meters, which has to be loaded into a cargo hold and be within the intensity and linear limits. The floor loading limits are intensity 800 kilograms per square meter and running 600 kilograms per meter. Let us start by calculating the three possibilities for the floor intensity, starting with the maximum intensity. To find the maximum value, we divide the mass, 1000 kilograms, by the smallest area, 0.5 by 1.5 square meters, which becomes 1333.3 kilograms per square meter. To find the middle intensity load, we divide the mass, 1000 kilograms, by the middle area, 0.5 by 2.5 square meters, which results in 800 kilograms per square meter. For the third option, we must divide the mass, 1000 kilograms, by the largest area, 1.5 by 2.5 square meters, which comes to 266.7 kilograms per square meter. We must now calculate the three options of running load, starting with the maximum, which is achieved by dividing the mass, 1000 kilograms, by the shortest length, 0.5 meters, which comes to 2000 kilograms per meter. The middle running load is found by dividing the mass, 1000 kilograms, by the mid-length, 1.5 meters, which gives us 666.7 kilograms per meter. The third option, the minimum running load, is calculated by dividing the mass, 1000 kilograms, by the longest length, 2.5 meters, which gives us 400 kilograms per meter. Looking at all of the options that we have calculated, it should now be apparent that the box of mass 1000 kilograms can only be carried on either its middle or largest area and subject to the longest length being at right angles to the cargo hold underfloor frames and parallel to the aeroplane's longitudinal axis. The solution is shown on screen with the two options. To overcome a problem of concentrated loads or items with sharp areas being placed in the hold, 2-inch thick timbers are placed between the load and the floor. This method assists in spreading the load over a large area and protects the floor from damage due to sharp items. There is a variety of securing and fastening devices used to ensure that loads situated in the cargo hold are fully restrained. The cargo hold incorporates various fastening points, and the restraining devices are allocated a proof strength to avoid failure. On screen, you will see a list of basic cargo restraint devices. During this lesson on cargo handling, we have learnt the various methods of locating cargo in the aeroplane's cargo holds, and how important it is to comply with the floor linear and area loading limits. We have learnt by calculation the acceptable way to place loads on the cargo compartment floor to avoid structural damage to floor and frames. We also know that there are a number of ways in which the cargo can be restrained in the hold to prevent movement.